If you mess around with Commodore 64s, there are a couple of essential tools you may want to consider getting: the DesTest, the diagnostic cartridge, and the test harness. Unfortunately, the DesTest cartridge only does very basic RAM tests and often misses marginal chips. On today's episode, we are going to build a test harness for the diagnostic cartridge and build a new cartridge to test the RAM, the DesTest MaxSwitch. Unlike the old DesTest, this cartridge does a proper March B test and is much more likely to find a marginal chip. To make this possible, we need some help from the sponsor of this video, PCB. So this project consists of several small PCBs and a whole bunch of connectors and cables. I obviously got the PCBs from PCB, and most of the connectors and cables came from AliExpress. I also grabbed a few things from Mouser. So this is a fairly new project, and I think this is an improved version of this card. I think the original card had some limitations of how much RAM it could test. But this is the MaxSwitch, so it should be able to test all 64K. And for this PCB I went with some gold, because it's going to be pulled in and out of a slot many times. And this way it should last a bit longer. And these cards are designed by a chap called Matthew Desmond. I'll put some information on the screen here where you can find the PCBs. I found the bill of material online, but I don't think we need it because all the values are in the silk screen. Well, everything except these two LEDs and a push button. And some pin headers, but they're kind of obvious. I would need to check how to set the jumpers here, but aside from those, I don't think we really need any instructions here. So these first 4 resistors here are 10K. And then we have two 390 ohm resistors, and they seem to be connected to these LEDs. Okay, and then we need some 0.1 micro caps, and apparently these have the wrong lid spacing, but I have a small assortment, so let's check and see if I can do better. Otherwise we're gonna just have to bend the leads. Okay, apparently I've had this issue before. These should fit. And we need 3 of those. And here's a bent one. So we'll have to bend it back. These guys fit perfectly. It's always good to have a few caps and resistors in your stash. That way you don't have to order every single component when building something. And then we need 2 sockets. Apparently I have used those resistors to test something on a breadboard, because the leads are chopped off. But that of course doesn't matter. Well, actually it does matter, because they are a bit tricky to unbend. Being so short, I have to use the tweezers. I used to do a lot of stuff on breadboards, so I kept a few resistors and caps with pre-cut legs, to make my life a little bit easier. And I'm glad I did, because I forgot to order more. Next we need a green LED and a red LED. I'm not going to be too picky and check the forward voltage on the recommended part numbers. I'm sure these are good enough. They are 1.8 volts. Next we need this push button here. Luckily I have 2 of these in my stash. I guess I need to order more resistors and push buttons. Okay, I had to check the manual about those jumpers and pin headers. And apparently they're not needed, but we have to bridge the 2 pins marked IO1. Okay, and we're done with the soldering. I actually keep everything we have used so far in my stash, because these components are so commonly used. I'm pretty sure I have the logic in my stash too. I actually ordered new chips from Mouser, because the logic I have in my stash is from AliExpress, and they can sometimes be rebadged from a different series. And I want to make sure this tester works as intended. Actually, not just for Commodore 64s. I will probably use my Commodore 64 to test chips from other systems too. So first we have a 74LS74, and this guy is a flip-flop. And then we have a 74LS02, and this guy has a bunch of NOR gates inside. So pretty standard components, and the last thing we need to install is an EPROM. But there is actually something fishy going on here. I haven't read the manual yet, so I'm not sure why. These guys are 16K, but the bin file is 8K. But we'll give this a try and see if this works. And if not, I guess I'll read the manual. I have used my TL866 so much. The damn ZIF socket is worn out. So I have to keep removing and reinserting the stupid EPROM a bunch of times before I get a good connection. Not sure if it makes sense to replace it or just buy a new one. Okay, I finally got a good connection. I was able to program it. Okay, and the cartridge is done. But we also need a harness. So let's build some more. And unfortunately I wasn't paying attention when I was ordering parts. So apparently R1, 2, 5 and 6, they need to be 110k resistors with 1% tolerance. That is a bit of an odd one, so I don't have it in my stash. Okay, so what I'm gonna have to do here is to go through my 100k resistors and 120 and see if I can find some that are as close as possible to 110. And unfortunately I couldn't find anything. They are very close to 100k or 120. So we're gonna have to bodge. Well, I found a couple of 220k resistors here that are quite close to actually be 220. So we're gonna use these. The through holes are actually large enough to piggyback the second resistor on top of the first resistor. This is gonna look pretty crazy, but I think this should work. Now that is a lot of leads coming up through those through holes. But what can I say? I wasn't paying attention, and I guess next time I order parts I'll pay more attention. That looks pretty bunkers. But hey, if it solves the problem, I'm not gonna care too much. And since they are connected in parallel, we're now getting 110.2k. So that is actually within specs of 1%. That's awesome. Totally fixed the issue. Okay, none of the other resistors gave me any trouble. So we can install the diode. Standard part that I have plenty of in my stash. The caps on this board are those same 100 nanofarad caps as on the DesTest card. So I'm gonna have to bend the leads to make them fit on this PCB. Okay, I installed the sockets too. So next up we have the LEDs. And these are much smaller than on the DesTest cartridge. I think these are 3 millimeters. And the larger ones are 5. But don't quote me, it's been a while since I checked the datasheet for an LED. And next up we have the cheap IDC connectors from AliExpress. But I'm sure they are good enough. They are basically just fancy pin headers. So if you don't feel like ordering these connectors, you can just use regular pin headers. I have to say I rather enjoy building projects like this, especially small ones like this. Large projects can be a pain in the butt, like the Sound Blaster MCV. I think it took a full day to build that card. Well, I still enjoyed it, but it really tested my patience. Okay, we're almost done with this PCB too. And next up is the edge connector. I went with the fancy edge connector from Mauser, rated for 250 volts 5 amps. That's an overkill, but they didn't have any single packs at AliExpress when I ordered parts, so this edge connector ended up being cheaper. The spacing between the pins, however, is quite a bit wider than the PCB, so I need to bend the pins. I'll solder one of the pins first and make sure it's straight. And now I can solder the remaining pins. And the final step is to install these 4066s. Now these guys just have a bunch of switches inside. Simple stuff, but very useful in many projects. And now this PCB is done too. I'll wash the PCB later, as always. Okay, next up we have the cassette dongle. And all the values are written on the PCB here too. So first we have R1. That's a 330 ohm resistor, and apparently the same value for R2. And then we have a transistor, and we need to bend the leads to make it fit. This guy is a BC547. This board too has a red LED. Apparently I got some solder in the through hole here, so I need to remove it before I can install the green LED. Let's try with some wick. So I don't need to heat up the desoldering gun. Yeah, that totally worked. And now we can install the green LED. And polarity is clearly marked on the board too. The R3 here is a 10k resistor. And the last part to go in is the IDC connector. Actually, not quite the last part. I also need an edge connector here. And I must have been in a hurry when ordering parts for this project, because this is what I got. I thought I ordered a connector from the same series as on this PCB, but apparently I didn't. I mean, I'm sure it will work, but it's not ideal. Well, in that case, we're gonna have to make a mess with the Dremel. Wow, what a mess. But now we have the connector I thought I ordered. I chopped off those long leads to make them fit. This PCB is finished now too. The next and the final PCB needs female pin headers soldered to the side here. I checked, but I wasn't able to find pin headers with bent pins. So I'm going to use a regular strip, cut it to size and bend the pins manually. Okay, said and done. But I'm not sure if this is going to be strong enough. So I think I'm gonna add a splash of glue underneath the connector here and glue it to the PCB before I solder the pins. That should definitely make it strong enough. Okay, said and done. The pins aren't really coming through to the other side, so I'm going to solder the connector from this side. I'm gonna key this connector by installing a pin from a pin header and cut it flush. This way the connector can't be installed on the PCB incorrectly, because there is a pin on this side, but not here. So if I try to install it backwards, it won't fit on the motherboard. I installed an LED and a resistor, but then it got tricky again. Apparently I was supposed to order IDC connectors with angled legs, but I don't think it's necessary. I think there is room enough to just install it like this. And if it doesn't work, I'll replace it with something else. And all 4 PCBs are done. And next we need some cables for all these IDC connectors. I managed to find some of them pre-built, but we'll at least need to modify some of them. Okay, so this guy connects here, and the other side goes onto this PCB. So this one is easy. And then we have a cable for the keyboard. So this one is easy too, but the remaining 2 cables need to be modified, because I wasn't able to find cables with joystick ports attached at one end. So to fix this, I cut the connector off one side, and then I pushed that cable through the strain relief on the joystick port, and then back in again, and make sure that pin 1 corresponds to pin 1 on the joystick port here. The joystick port only uses 9 pins. But our cable here has 10 wires. So I've also cut the last wire off. And then push the cable into the connector. And next I'm going to put the connector in a vise. And push the whole contraption together. Actually, I didn't need to bring out the vise, because regular pliers did the job easy enough. I went through my stash again and I found some angled pin headers. So I replaced the IDC connector on the keyboard dongle. This way it's pointing in the right direction. I think it's deliberately designed this way, so you can test the board without having to remove it from the Commodore. And with the cable going upwards, it's not pushing against the case. And the last part is the easiest part, and that's the IEC dongle. And for this we need a 5-pin DIN plug. The DIN plug doesn't actually connect to anything, so it doesn't need a cable. But we need to bridge a couple of the pins. So I'm going to use tiny pieces of wire and bridge these 2 guys here. DIN plugs have a bad habit of melting very quickly. So don't linger with the tip on the pin. And then we need to use an even smaller piece of wire and bridge these 2 guys. Wow, that was easier said than done. Okay, and I think we're done with all the soldering. That was the last part. We're done. And at this point I decided to flip through the manual And I realized my mistake here. So now I know why the bin file was only 8K. I had downloaded and programmed the wrong file. So that has now been fixed. And the correct file is of course 16K. I also somehow missed one of the caps. So that has been installed too now. Okay, time to test stuff. I'll start with the DesTest cartridge. I grabbed the Commodore from the top of the pile. I don't remember what we have done with this machine. But being on top of the pile, it's the last machine we have used, so it's quite likely to work. Okay, here goes. Okay, DesTest switch 4K memory pretests. Okay, so now it's testing the first 4K of memory and showing us some funky characters and colors. Okay, and I think it passed the test. And now I think it's supposed to switch to the remaining 60K. Well, I've been waiting for several minutes here and nothing is happening. So I think we have an issue here. I think it's supposed to switch from the 4K test to the remaining 60K now. But it isn't. It seems to be stuck. So let's reboot. Okay, running the 4K tests. Unexpected break. Okay, that sucks. Reset again. An unexpected break again. Okay, so either this Commodore is broken or we have an issue with the card. I'll do one last reset. We're getting unexpected break again. Okay, time for some troubleshooting. Unfortunately, we're not doing too well here. Tested the card with 2 other Commodores, but I got the same behavior. So the issue is with the card, not the Commodore. So I have checked the values of all the resistors and they are good. The 2 logic chips, as I mentioned, are brand new chips from Mouser, so they should be okay too. So then I burned a new EPROM, but I'm still getting the same result. And this is also where my TL866 gave up completely. So I'm not getting a good connection with the old ZIF socket anymore. But to finish this video, I took the TL866 apart, removed that stupid ZIF socket and installed a regular 40-pin socket. And that way I was able to burn a new EPROM. I ran out of 27C128 EPROMs, so I had to install some pin headers and a jumper here. That way I was able to use a 27C512. And I have burned it 4 times, because these old EPROMs can be a bit stubborn sometimes. But nothing so far has helped. So the only thing I haven't tested on this card are the caps. They're not very likely to be faulty, but that's the only thing I haven't tested. So I guess we'll test them too. I've never had any issues with ceramic caps, so they're not very likely to be faulty. But I guess they could have been marked incorrectly before they ended up on AliExpress. Or maybe they have been sorted in the wrong bag. I tried to measure these guys in circuits, but that didn't work. So let's check the values. Okay, 118 nanofarads. That is 20% more than they should have, but this shouldn't be a problem. This guy measures 130, so they are a bit off. But I seriously doubt that this should make a difference. 117. And the last one, 50. Well, that's quite a bit off. Could this be our issue? Well, I guess it's possible. And it's the only thing I haven't tested. I guess I'll grab 4 new caps and check them before I install them. Okay, caps replaced. Fingers crossed. It's running the 4K tests. We're getting all the funky graphics, but it still doesn't switch. Seriously, what's wrong here? I've tested every single component on this card. I don't get it. There's nothing else to test. What the heck could be wrong here? Okay, next I downloaded a fresh copy of the bin file and made a new EPROM in case my copy was damaged. Here goes. It's running the tests. Now let's see if it will switch. No, unexpected break. the heck is going on here? Everything on that card has been tested, and I've tried it on 3 different Commodores. I can't possibly have the same fault on 3 different Commodores that appears to be working. This must be some weird compatibility issue. Okay, I actually found something interesting here in the manual for DesTest Kernel. This is a version of this test running directly from an EPROM, installed instead of the kernel ROM, directly on the motherboard. And this manual actually mentions the break error. If you see this screen, then the CPU has somehow executed the break instruction. This might indicate marginal 6510, PLA or other chips that is affecting data reads. I still don't find it very likely that I have 3 machines behaving in the same way, but I guess it's possible. I don't have the matching 2464 EPROM, since they are pretty much impossible to find nowadays. So I grabbed the 27256 EPROM using an adapter. I installed it on the motherboard. I used the copy B command in DOS prompt and combined the ROM twice to go from 8K to 32K. And then I burned a new file to the EPROM. So let's turn the machine on and see if this works. And I think it is. And now it's testing all the 64K right away. Okay, and it's done with the 0 to 4K tests. Now let's see if it gets stuck. Well, this is taking its time, so I'll skip ahead here. Okay, and now it finished the 4 to 32K tests. Okay, I went for lunch and came back to this. From what I can tell, it has looped the test 12 times. And since I have never used this ROM before, I'm gonna have to assume that it would have told me if it had found any errors. So there's actually nothing wrong with this Commodore. And our issue here is with the switch card. But I have tested every single component on that card. So unfortunately I don't know what's going on here. Well, I'm grasping for straws here. So next I decided to burn a 3rd EPROM, just in case we have 2 bad EPROMs. Here goes. And it starts up normally. And it's testing the first 4K of RAM, just like previously. Now let's see if it will switch. No, it doesn't. So it wasn't a bad EPROM. Okay, I decided to test it with 1 more Commodore. And we're still getting the same behavior. So now we have tested the card with 4 different machines that are otherwise perfectly working. Well, we have checked the resistors and the caps, and we have replaced the EPROM 3 times. So the only 2 untested components here are the 2 logic chips. Unfortunately, I don't have any spare, so I can't swap them. And I can't test them, since my EPROM programmer is so messed up. Well, I guess this issue could be caused by a bad EPROM programmer. And I guess I'm gonna have to order a new one in any case. But unfortunately, I am at a loss here. There is nothing else I can try. And these 2 chips are brand new from Mouser, so they are extremely unlikely to be faulty. But I guess it's possible. So this part of the video is unfortunately gonna have to be a partial fail. But not completely, because the DesTest kernel is pretty awesome. And we now have a much more comprehensive way of testing for the 164 chips. I will get back to the switch card when I have found why it's not working. But for now, I just don't have anything else I could try. I know these cards work, because I have seen other people use them. But unfortunately, one of the components seems to be messed up on my card. And I just don't have anything else I could try. I will of course get back to this card when I have found the fault. And for now, I could just use the kernel version here. This may actually be a better option if your kernel is installed in a socket. This option here is actually much quicker and cheaper. But if it's not, and if you don't want to desolder it, then the switch card is the best option, of course. And now let's move on and test the test harness. Now this is an old project. It's been around as long as I can remember. I think Commodore service centers use something similar. This is basically a clone of what they had back then. And the test harness is designed to be used with the diagnostic cartridge 586220. The diagnostic cartridge can be used without the harness. And if we turn the Commodore on, it starts running a bunch of tests of the machine. But without the test harness, we're getting a whole bunch of errors, because this cartridge is designed to be used with a test harness. And without the harness, it can't do all those tests. I deliberately went with a very long cable for the keyboard, because on short boards, the keyboard connector is at this end of the board. and hopefully it's long enough to reach this side of the PCB. And I can use it for shortboards too. Okay, let's turn the machine on with the harness connected. And I actually remember why I have this machine on top of the pile now. We were being silly with it and connected it to the 275 MHz 5500. That must have been the world's first and probably last. That was pretty silly. Okay, and we're still getting a cassette and keyboard bad. Serial port and user port. Okay, that's weird. What's going on here? Well, I forgot to plug in this dongle here, but that doesn't explain all the errors. I'll try with some deoxit. We may have a bad connection here. So I'll add some deoxit to all the edge connectors and let it do its magic. I'll connect the card and disconnect it a few times in case we have some corrosion here. It should be enough to remove it. Okay, let's try again. So the green LED flashed on the cassette dongle. It lit up on the keyboard dongle. And both the red and the green LED lit up on the main PCB. Okay. Now the test passed for cassette, keyboard, control port, serial port and user port. Awesome. So 2 out of 3. Now I can test my Commodore 64s much more efficiently. So up until now I have basically had to test all my Commodores with a floppy drive, a cassette deck and joysticks after every repair I have done. So this is much quicker and more efficient. And I just remembered to check my stash to see if I had any of those logic chips. And apparently I do. Now these may not be LS chips, but it's worth a try anyways. Actually this one is. It's a 74LS02 from 1983. And I've had this chip since I was a kid actually. I can tell because this is the foam pad I used back then. But these flip-flops here, they are from AliExpress. And these guys are 74HC74. So they may actually not work on this card. But hey, it's worth a try. Oh crap, one of the legs is broken. But I guess I could solder a short piece of wire instead of that leg. That should be good enough for a test. Well, the pins were actually quite crusty on this chip. So I ended up soldering it to a socket. This way we know for sure we get a good connection. And I used the machined socket. That way the pins won't crush the socket soldered to the board. By the way, I tried with yet another EPROM. And this guy here is 27C512. So I installed 2 jumpers on these 2 pin headers. I only replaced the 7402 for this test. Now let's see how it behaves. I mean, it clearly says DesTest switch here, so this should be the correct ROM. Okay, it's testing the first 4K. And still unexpected break. And for this test I replaced both chips, but the 74 is an HC chip. And for this project LS chips are specified. Okay, but it seems to be working, well, at least as far as before. Now let's see if it will switch. I also checked the soldering, but unfortunately unexpected break again. So this video got delayed because I really wanted to get this card up and running and make sure I had tried everything I could. Next up I'll order a set of new logic chips. And I guess I need a new programmer too. If you want to support me, consider becoming a patron. Before you leave, hit the like button and subscribe for more vintage computer restorations and mods. And I'll see you guys again next week.